Welcome to Engineering Chemistry. Today I am discussing about the topic ion exchange process or deionizations or demineralizations. Ion exchange process includes the exchange of the cations and anions of the dissolved salts with the H plus and OH minus ions. Here, for the ion exchange process, we have to use the two types of the ion exchangers. First one is the cation exchanges. Cation exchange. That is cation exchange resins. Here you have to use the resins. And the second one is the anion exchange resins. Here the cation exchange resins are the capable of exchanging their H plus ions with the cations of the dissolved salts. With the cations of the dissolved salts, the cation exchanges are represented by the general formula RH. RH, and they are mainly styrene divinyl, benzene copolymers containing the functional groups of COOH or SO3H. They become capable to exchange their hydrogen ions with the cations in the water. The second one is the anion exchangers. Then anion exchange resins are the phenol formaldehyde or amine formaldehyde. These are also copolymer resins which exchange their OH minus ions with any anions present in the dissolved salts. These after treatment with dilute NaOH solutions, it will become capable to exchange their OH minus ions with anions in the hot water sample. Here the ion exchange process, we have to use the cation exchange resins and the anion exchange resins. Now what is the process involved in the ion exchange process is here we have to take the one diagram, that is the ion exchange process diagram. Here raw water is passed through the, first of all, here three chambers are there, that is the cation exchangers, anion exchangers, and this is the degasifiers. Here first of all, we have to take the raw water. Raw water is passed through cation exchange column where all the cations like calcium and magnesium present in the hot waters are removed and equivalent amount of the H plus ions are released from the column to the water. After passing through the cation exchange column, the hot water is passed to the anion exchange column. This is a anion exchange column where all the anions like SO4 2 minus etc., that sulfur anions are here present in hot waters. They are all are removed in anion exchange columns, and the amount of OH minus ions are also released from the column in the water. And here the water is here cation is removed, and here some of the anions is removed. Now the water is free from the anions. Thus this water comes out from the exchanger is free from the ions, and these are known as a deionized or demineralized water. When water sample is completely deionized, it has the tendency to absorb the some of the gases like CO2, O2, etc. Okay, and after that complete these cation exchanges and anion exchanges, we have to pass through this water into this column, that is the degasifier. Here the any some of the gases like CO2, oxygen, or some of the gases are present in the water sample will be removed in the degasifier chamber. Hence deionization must be followed by degasification. Deionization is completed, after that degasifications. After that Regeneration process. After that, regeneration. This regeneration is carried out by passing the dilute HCl or H2SO4 into the solutions into the bed. The H plus ions of the acids are exchanged with the cations like Ca2 plus and Mg2 plus present in the cations exchanges, and they regenerated like R2Ca plus 2HCl will gives 2RH plus calcium chloride, and R2Mg plus H2SO4 will gives 2RH plus MgSO4. These two are the washings. Here the washings contains calcium chloride and magnesium sulfate were passed into drain similarly, and they exhausted anion exchanges, and it is treated with the dilute NaOH solutions. Then the regeneration is mainly carried out by representing by R21SO4 plus NaOH will gives 2R-OH plus Na2SO4. Next, R1 chlorine NaOH will gives R-OH plus NaCl. These two are the washings. Next, R1 HCO3 again react with NaOH will gives R-OH plus NaHCO3. Next, R-NO3 plus NaOH will gives R-OH plus NaNO3. These two are also washings. Then the washings are discarded. These two are the washings, and these washings are discarded into the sink. Thus deionized regenerations are the alternate process, same like this. Okay, this is about the ion exchange process. And what are the advantages? What are the advantages of the ion exchange process? It is a high acidic or alkaline water. The alkaline water sample can be purified by this process. And the second one is the deionized water must be suitable for the high pressure boilers only. And the next one is that the hardness passed by the deionized water is only 2 ppm. The hardness passed by the deionized water is only 2 ppm. These are the three are the advantages. And disadvantages are the ion exchange resins are expensive, hence the cost of purification is high. Cost is high. Next, raw water should contain the turbidity below 10 ppm, and otherwise pores in the resins will be blocked and output of the process is reduced. Mainly the turbidity of the water is below 10 ppm. It will be used, and that means otherwise pores in the resins will be blocked and output of the process is reduced. These are the two or the disadvantages of the ion exchange process. These are the advantages, this is the disadvantages, this is the regeneration, and this is the cation exchange resins and anion exchange resins. This is about the ion exchange process. Thank you very much.